right? Everything is AI these days, right? From I mean, you guys know what I'm talking about. Everything is interpreted as AI for good reasons and for not for some good reasons as well. So let's try to understand what is AI. That's number one. I'll try to give a very sort of a intuitive definition of AI, and then we'll try to move towards evaluating techniques. That's something that I would like to spend a little bit of time on. What you will not get during this webinar is how to develop AI, right? I mean, that's obviously that's a different topic altogether. Obviously, something which cannot be done within an hour's time, right? So you can think of it like this. So let's say, many of us drive cars, right? But it doesn't mean to drive a car, right? You need to know what's going on behind a car, right? So AI is something like that. All of us can be users of AI, but it doesn't mean that all of us, need to understand how to build AI, right? So I'm trying to basically give you some pointers as to how to be users of AI more than as opposed to how to be builders of AI. All right. All right. So we all know, AI is artificial intelligence, right? But then I think we ask ourselves, what is intelligence, right? That's a good place to start, right? So what is intelligence, right? Let's start our discussion from there. So according to research, right, intelligence is defined. Well, okay, guys. So this is supposed to be a joke, right? So of course we are not going to read through this. So let's forget about the formal definition of intelligence. This is what we are going to do, right? Rather than trying to define intelligence, right? Let's talk about some of the key capabilities that are associated with intelligence, right? So that's what we are trying to do here. So what are the key capabilities which is associated with intelligence, right? One thing is ability to see and comprehend, right? Comprehend or understanding what you see. It's a big part of intelligence, right? Or a very big skill associated with intelligence, right? So this is the difference between a camera lens and our eye, right? Because camera lens can also see, right? But there's no comprehension, right? But when we see something, we understand something, right? If we look at something, we know, okay, it is of this color, right? If we see a person, we know if it is a male or a female, right? So there's a comprehension. So that is one of the key capabilities around intelligence, right? Or key capabilities associated with intelligence, right? Similarly, so we can hear and we can comprehend, right? So that's the difference between a mic and a human ear, right? We can comprehend, right? We can comprehend language, right? We can comprehend noises, right? And we predict certain things based on what we hear, right? Certain noises, right, have certain interpretations, right? Some are nice, smoothing. Some are nice and soothing. Some are warnings, right? So there's some element of comprehension, right? So that's the point that I want to like keep stressing. So it's not just the ability to see or ability to hear, but to comprehend and understand, right? So that's one of the key things behind intelligence, right? Reading is the same thing. So even though we are not going to define intelligence, right? One of the big part of intelligence is ability to consume information and comprehend, right? That's one of the key capabilities associated with intelligence, right? Guys, if the line break up, Amanda or someone can, you know, just give me a heads up, okay? It's all right. Right. Now then the question is, okay, how do we gain these capabilities, right? So we can see and we can comprehend, we can hear, we can comprehend, we can read, we can comprehend, right? How do we get these capabilities, right? Now look at this picture, right? The picture that you see on your left, right? There's a baby, right? So straight away, we know it's a baby. Is this a baby girl or a baby boy, right? And now we know it's a baby girl, right? But if you show the same picture to a 3-year-old kid, right? The answer may not be that clear, right? That there's a chance that this 3-year-old baby will say this is a boy, right? There's a chance. So how do people learn actually, right? I mean, how do people gain these capabilities, right? So we know that, as an adult, we know it's a boy, it's a baby boy again. But a 3-year-old may not be able to do this this easily, right? So how do people learn, right? People learn through. I think there's a mic which is unmuted. Lots of background. Okay, thank you. So how do people learn? If you look at some of you, I'm sure have kids, right? How do you teach them, right? Whenever they make a mistake, you correct, right? So if someone looks at this picture of the baby boy and someone says, okay, it's a girl, right? You will correct it instantaneously. You'll say, no, it's a boy, right? So this process of learning, right? It's associated with constant reinforcement. So usually you learn through continuous reinforcement, right? And that's the most important thing, right? So we talked about intelligence. We talked about some of the capabilities associated with intelligence. And then how do we gain these capabilities, right? It is through continuous reinforcement, right? And so where does this continuous reinforcement thing happens, right? It's in human brain, right? So there's something called, our brain is, it's a, you have like billions of neurons, right? A little bit of biology. I don't know much about it as well, but there's a neural network of billions of neurons, right? So it stores information, right? And whenever something gets reinforced, right? So it learns from it, right? So that new information gets stored in the brain, right? And through that, we learn to comprehend things over time, right? That's a point I really want to make. It happens over time, over continuous reinforcement, right? We can do lots of things that a 3-year-old can't do because that reinforcement process has not happened, right? So the learning happens through continuous reinforcement. And I think now we have a good framework to define artificial intelligence, right? Now, what is artificial intelligence, right? So a machine that has capabilities which is closely associated with intelligence, right? We can call it a machine with artificial intelligence, right? Is it clear? I hope it's clear to everyone, right? So we talked about some capabilities associated with human intelligence. So if a machine has those capabilities, then this machine has artificial intelligence, right? So it's as simple as that. Yeah. So so if a machine can recognize an image and understand something about the image, right? Again, I'm really stressing on this point, understanding, right? So that's the difference between your human eye and a regular camera, right? It's not just the image, but you should be able to understand about the image, right? So if there's a machine which can actually recognize an image and understand, comprehend something about the image, right? Then that machine has artificial intelligence, right? Voice again, recognize voice and comprehend, right? Can read and comprehend, right? Now we talked about how people gain their intelligence. It's through the neural network or the mechanism in our brain, and we basically do the same thing with the machines, right? So it is called artificial neural network, right? So we can develop this algorithm, right? Called artificial neural network, ANN, right? And we can basically, this algorithm mimics what happens in the human brain or what happens in the actual biological neural network, and we sort of artificially try to mimic it. So that's what we call as an artificial neural network, and the process is exactly the same, right? The artificial neural network also learns through continuous reinforcement, right? So there has to be that reinforcement process, right? So it will say something. If it is right, we have to externally, we have to say, yes, this is right. If the machine says something wrong, externally, we'll have to say, no, that's wrong. This is the right thing. And once we do that process over and over again, just like a human baby learns, the machine also learns over time, right? So just to summarize this small section, I want to emphasize. Okay, we talked about intelligence. We even though we did not define intelligence, we sort of loosely defined it as a set of capabilities, right? And we talked about how we gain these capabilities. That's the process of reinforcement. And then we said, okay, machines can also have this artificial intelligence by training a neural network through the reinforcement mechanism, right? So if you have trained a machine to have those capabilities through a reinforcement mechanism, then that machine has artificial intelligence, right? Okay. Now, this slide, it's supposed to be a quiz, right? Now that we've defined artificial intelligence, I basically looked at some cases. Some of this is actually applications of artificial intelligence. Some of it is not. So I called the first group as AI, the second group as cool but not AI. Okay. Now, again, the point that I want to make is, I mean, I purposely call this cool but not AI, right? Everything doesn't have to be AI to be cool, right? There's lots of tech which is not AI, but still very useful, very handy, very effective, right? So, so let's keep that in our mind, right? Everything doesn't have to be AI, even though AI is this sexy, cool thing. But we should be able to objectively understand what is AI, what is not AI. Now, okay, well, the first thing. Okay, guys, there's a small issue. I want to see the chat while sharing the screen. Not sure how to do it. I don't know if anyone can help me here.
Shankha, there is a icon show conversation. You can, it's on that bar where you say hang up, and then there's show participants, and then there is chat. So if you can click on that, you will see the chat.
Yeah, I can see the chat, but then I can't share the screen. I can't see the screen that I'm sharing. That's the thing. Okay, anyway, you guys still see the screen that I'm sharing, right? I think I'll just have to toggle back and forth.
No, we can see your screen, Shankha.
Okay, yeah. All right, guys. So the first one. So the Google self-driving car, is it AI or just, cool but not AI? Let me look at the chat. AI, okay. Okay, everyone says it's AI. Okay, it's AI. I think it's clear, right? So think about this car, right? So we talked about certain capabilities associated with AI, right? So the car obviously has a bunch of cameras, right? But it can actually see stuff, right? And based on that, it can understand certain things, right? Once it sees, as an example, once it sees a red light, right? It understands, okay, that means you need to stop, right? So it has built this comprehension, right? Not just seen, but comprehension, right? And how do you think Google trained this car? Through continuous reinforcement, right? So, so when there's this red light, they brake. Someone actually manually brake. So that's the reinforcement mechanism, right? Then the artificial neural network learns, right, through that reinforcement process. Okay, when I see this red light, right, I need to brake, right? So then this process has happened. So that's why Google started this project in 2005, right? Probably, but the first ride, the first driverless ride happened in 2015. So during a period of 10 years, right, they were actually training this model, doing this reinforcement, right? So there has to be that reinforcement process for it to be AI. That's a point that I think I'm going to keep saying. Production monitoring dashboard, a real-time dashboard which has information about the current production status of multiple assembly lines. Is it AI or just cool tech. Yeah, that's cool tech, right? Yeah. Everyone got it correct. It's just cool tech because there's no reinforcement, right? No one's teaching it anything, right? So it's just cool tech. So my target group. So let's say there's a campaign manager, right? So if I'm sure some of you guys are in marketing, right? So let's say there's a campaign manager, right? A new campaign manager. Right? It's called my target group. So it lets you decide who to target from your loyalty base, right? So you can come up with a decision, right? I want to target people who are between 40. You can look at your CRM as an example, right? I want to target those who are between 30 to 40 years who have made a purchase over the last 2 months, or who have not made a purchase over the last 2 months, right? Depending on whichever thing you want to do, right? Depending on if you want to just do some upselling, cross-selling, or depending on you want to do some churn management or retention management, right? So it lets you do that. Is it AI? Not AI. Cool, not AI. It's not AI, guys. Again, what's the reinforcement process? That's the critical question you should ask. Okay, if there's no reinforcement process, if there's no learning process, right, then it's not AI. So right now I think it's clear to everyone. So let's go start fast. Office fingerprint scanner. AI, not AI. Yeah, not AI. Yeah. Okay, number 5. A system that tells me the customers who will churn or lapse, right? That's going out of your system or network during next month, right? So there is a system. So someone's selling you a system that tells you the customers who will churn next month. Is it AI? Not AI. AI, not AI. Okay, now we have a debate here. Someone says, yeah. Is it A? Does it mean it's AI? Yeah, okay. I think you guys get the flavor, right? This is exactly what I expected. Well done, everyone. Very well done. Because unless you ask some follow-up questions, right? Unless you ask some follow-up questions, you won't know if this solution is AI or not AI, right? So what is the follow-up question, right? So we need to know if this system learns, right? So that's the important thing. So the follow-up question would be, how do you actually do this, right? How do you predict churn, right? So if the system is configured in a way such that, let's say, you look at people who have purchased, right, or used your, whatever the service that you provide over the last month, right? And then it looks right. Sorry, I probably lost my train of thought. If the system looks at people who have not used your service, right, over the last month, and then it tells you, okay, these are the people who will actually churn, right? Then that's not AI, right? Because it's based on some kind of a fixed rule, right? There's no learning process, right? Is that clear to everyone? If it's based on a fixed rule, right, that you or someone else defines, right, then there's no continuous learning process, right? It's based on some kind of a fixed rule, right? Then that's not AI, because there's no reinforcement process there. Okay. But if there's a reinforcement process, now this is how the reinforcement process will look like, right? The system will say, okay, these people will churn, right? So it will predict something, and then the next month the system will actually know who have actually churned and who have actually not churned, right? So that's the reinforcement process, right? So system gets that information. Okay, I said this person is churning, but that person has not churned. So the system itself, the neural network, the artificial neural network, changes certain parameters to basically correct itself. So then that becomes AI, right? Just like the baby who learns, right? When that baby wrongly said, okay, that's a baby boy. When someone tells no, that's a baby girl, right? Then our neural network up here learns that. So just like that, if the system learns, then it's AI. If the system does not learn, if it just based on some static set of rules, then it's not AI. So I think you guys are right. Yeah, absolutely. It depends. It depends, right? It depends, right? So someone has just said it depends if it predicts. So prediction is not what you should look at. Prediction, just because you predict something, it doesn't mean that it's AI, right? Because you can predict based on lots of things, right? As I said, you can predict based on a simple rule. You can have a simple rule and say, okay, I predict these people will churn, right? So prediction is not the yardstick. The right yardstick is the learning and reinforcement. Okay. My phone that uses facial recognition to unlock. I think that's the easy one. Phone is actually AI, guys. It's AI. It keeps learning. It actually, that's why it gets it wrong, right? If the picture is not that good, if the image is not that good, if it's dark, right? It learns and corrects itself. How does it correct itself, right? So whenever it can't recognize your face, it doesn't let you log in unless you put the manually enter the pin, right? So then it learns, okay, I actually thought this is not the right image, but it is the right image because you have put the pin, right? So it learns. So that's the reinforcement process, right? Every time it does it wrongly, it learns and it gets better, right? So it's a standard application of AI. Just look at that learning element, okay? If it learns, it's AI. If it doesn't, it's not. A recommendation system on an e-com platform, right? Like lots of e-commerce platforms have recommendation systems. Is it AI? Is it not? When you buy something, it says, okay, why don't you buy this? Can't be either. Yeah, again, I think it depends. It depends. Again, it depends. So then, there has to be a follow-up question on that, right? How does it recommend, right? So if it recommends on some set of static rules, right? So let's say for everyone, every time it sells, it sells, let's say a gaming console, right? It basically recommends the say latest game, right? That's a static rule, right? So which is not AI. But if it can learn, if there's some learning process, right, then that's AI. So so for you to understand, depends is the right question. You will get to know only through a follow-up question. Okay. My last question. A system that alerts me on stockouts in advance, right? So let's say you are you're in sales, so you're into inventory management and inventory planning, right? There's a system that predicts this outlet or this distribution center going to be out of stock next month or next week. Is it AI? Not AI. So there's a predictive element, definitely. Not AI. Not AI. Okay. Again, the answer is the same answer. It depends. It depends if it learns or not. Okay. So you will only get to know through some follow-up questions, right? So what you should ask is very clearly, how does this happen? Okay. Is there some kind of a reinforcement process? There's a reinforcement process, then it'll learn and it'll get better, right? Then that's AI. If there's no reinforcement process, if it is just based on some set of static rules, right, which are predefined by someone, right, can be any person, right, it's not AI, right? But having said that, again, let me just reinforce, right? It doesn't mean that it's an inferior solution, right? You're not talking about what is inferior, what is superior. That's not my objective. Definitely, everything doesn't have to be AI. Sometimes, a simple rule can be very good, very effective, right? Sometimes, it might be very difficult to come up with set of rules, and AI can be, a reinforcement system can be much better, right? So it depends, right? All right, guys. I hope you got something out of that, right? What's AI? What's not AI? So I have some. So this is only 1 hour. This webinar. I have some. We have a separate Q&A at the very beginning, at the very end. Sorry, but if you have questions, just let them come, guys. We'll try to answer as much as possible. Okay. Now, the next thing I want to talk about is standard AI versus non-standard AI, right? Now, what do I mean standard AI, right? I talked about set of capabilities that are very commonly associated with human intelligence, like the ability to see and comprehend, ability to hear and comprehend, ability to talk, right? All of these are like capabilities, very, very highly associated with human intelligence. So whenever you try to replicate those, right, so that becomes very common, very standard AI, right? Like as the image recognition or unlocking mechanism in a smartphone, right? So that's very standard AI. The other problem that we talked about, right, as an example, a system that tells me the customers who will churn or lapse next month, right? So we talked about, depending on the follow-up questions, we'll be able to understand if this is AI or not AI, right? But I call it non-standard AI, right? I'll explain why I call it non-standard AI. Let me look if there are any questions. Okay, there are some questions. Okay, let me just first talk about the standard AI and non-standard AI, right? Now let's look at this image recognition problem, right? So the phone obviously takes a picture of mine, right? And based on that, it decides if it should let me you know unlock, right? Versus the non-standard problem, right? The non-standard problems have a data element which is much more complex, right? That's, for me, that's the biggest difference between standard and non-standard. Now, if you look at this image problem, right? So, each image, it has certain number of pixels, right? Each pixel has, 3 elements, right? The RGB. So if you have, let's say, whatever, 1024 pixels, let's say, and each pixel has 3 elements. So you're talking about 3 times 1024. That's the information that you're going to use to make this decision, right? Is that clear to everyone? That's it. There's no need, absolutely none, to use any other information, right? That contains 100% of the information that you need to make this particular decision. Now, once you have that information, yes, there are certain ways that you can manipulate this data, right? So in image recognition neural networks, right? There are certain feature engineering tasks, right? You pre-process data in a certain way, right? You identify the pixels which are at contours and so on and so forth, right? You do lots of complex things, but you do all of it based on a very, very nicely defined set of information. It's 100% predefined. You have 100% of the information you want, right? But in this churn problem, right, you have no idea, right? You're lucky if you can have 60-70% of information, right? So obviously you can get some information from your usage, from your CRM, right? Maybe you can get some information from social, right? But sometimes your decisions are not based on these things, right? Maybe it's based on, some person that you talk to, right? It's very difficult to get all the information about that particular chat that you had, right? Maybe it's a financial decision, and we don't have access to people's personal information. Maybe it's a health related decision. That's why this person churned. We don't have that information, right? So it's very, very difficult. So these non-standard problems, the data that you need actually to make this decision accurately, or to train this neural network, artificial neural network, is non-standard. Most likely that data is not even available, right? So in terms of data, non-standard problems become much more complex, right? I hope that is clear to everyone. Okay, is that clear, guys? The complexity of non-standard stuff. Yeah. Okay, can you give some examples of reinforcement methods or learning methods? Yeah, so I talked about how it done for humans, right? I kept talking about this baby girl, baby boy example, right? So it's the same thing which happens, right? I talked about the churn problem, right? So you predict someone churns, but after some time you will know if that person churned or not. So that information is looped back into the algorithm, right? So that's the that's the reinforcement methodology, right? Okay, now someone's asking, okay, what is narrow intelligence? Yeah, see, lots of AI, right? It's sort of narrow because it's right now where artificial intelligence is. You can train machines for narrow set of skills, right? Human-like capabilities, but it's very narrow. It's very well defined, right? You have chatbots. You can actually talk like human, very much like human, but it's narrow, right, to that particular thing, right? There are there are machines which can see just like humans, or maybe as better, or maybe even much better. But vision problem, I think humans are still much better. Um, you know, there are lots of defense applications in AI, right? You can look at something, you can identify if it is an enemy uh, or a ally, right? Based on that, you can basically activate a weapon, right? So this is a very specific capability, right? Yeah, yeah. Autonomous vehicles, game playing robots, absolutely. So all of these are very specific. If you're talking about general intelligence, right? Just generally, like humans can do so many other stuff as well, right? There are not a whole set of other emotions, right? With associated with our intelligence. We unfortunately we are artificial, unfortunately or fortunately, depending on where you stand on that debate. General artificial intelligence, right? It's a little bit further away, right? And I don't know. I don't know if it is 10 years or 20 years. It's probably not 10 years. It's probably beyond that. All right. Let me. So we are almost done. We have about 10 minutes left. I wanted to give you a little bit of details about a particular example of artificial intelligence, but I don't think I have much time to go into details. I'm going to skip. But I think we talked about lots of use cases during our quiz, churn or non-churn quiz. So let me skip those slides. One thing I want to talk about though is about nice to have AI and operationalized AI, right? So we talked about standard AI and non-standard AI. Now let me talk about nice to have AI and operationalized AI. Now, what is nice to have AI, right? Nice to have AI is, I think it's self-explanatory, right? It's just nice, right? It's cool, right? But if you're in a business, right, it doesn't impact your top line or the bottom line, right? Then it's just nice to have. So let's take this example, right? So we talked about this hypothetical churn problem, right? So let's say you could be in telco, you could be in insurance, right? You could be providing any kind of service to anyone, right? So you want to like retain your customers, right? That's one of your biggest thing, right? So if you don't retain your existing customers, right, it's very difficult to grow, right? So we talked about how we can probably use we can have a system which has artificial intelligence, which can actually help you with this churn prediction process, right? So you can actually train an artificial neural network through reinforcement. But the question is, even if this prediction is very good, if you are not taking any action on that prediction, right, it just becomes nice to have, nice to have AI, right? Yeah, we have a system which is very good, right? It accurately predicts people who are going to churn, right? It's really cool. It uses, this cool uh, 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 neural network, right? Deep learning algorithm, right? So it's nice to have, but how to make this operational, right? Now, to make things operational, to make AI operational, you have to like go a little bit beyond. That's when you have to, sometimes bring a little bit of human intelligence, right? We call this nowadays we call this augmented artificial intelligence, augmented AI or AAI, right? You sometimes have to augment this information with some other information, right? So let's say, you get this prediction, right? But to make this operationalize, right? To make it operationalize, what you really want to do is, okay, you have to come up with a mechanism where you will stop these people from churning, right? Now you have predicted that these people will churn, but now you have to stop them from churning, right? So how do you stop them from churning, right? Maybe you can give them a promotion, right? You can give them some kind of incentive to stay back, right? Now, how large this incentive should be, right? To decide that, maybe you need to like look at the lifetime value of this customer, right? If the lifetime value of this customer is, let's say 5,000 rupees, if you want to give an incentive of, I don't know, 2,000 rupees, probably it doesn't make sense, right? You probably want to give this 2,000 rupee incentive to someone who probably has a 20,000 rupee lifetime value, right? So there's another element when you try to operationalize it, right? So you have to look at, is it practical, right? I mean, so I have all these churn predictions. Am I going to target first 100 people? Am I going to target first 1,000 people, right? If I'm supposed to give a telephone call using my telemarketers, can I give a call to 1,000 people? Probably I don't have resources. I have a practical constraint there. I can only give 100 calls per day, right? Then, okay, let me look at the lifetime value, right? Let me look at some other parameters as well. So that's augmented AI, right? So you have to like bring few other layers into play if you really want to operationalize artificial intelligence. So it's important that you don't stop at nice to have AI. You should really try to operationalize. That's when people see value, and that's actually one of the biggest problems in machine learning, deep learning, in some of the big data related applications. Most of it turn out to be just nice to have stuff, and people at the end of the day don't see the value, and as a result of it, people lose faith in these technologies. So it's very, very important to operationalize it, solve a problem until it actually has a top line or a bottom line impact. That's very important. Okay, I'm down to my last slide. There's a very, very famous quote about big data. It's a very, very old quote, but I think it's very, very relevant. Even today, it's very, very relevant, right? And this problem of just nice to have AI, nice to have use cases, right? We see that very, very often, right? So I think you should be careful and you should, if you're a practitioner of AI, should make sure that you solve problems until the very end, until it has that top line or bottom line impact. Okay. The other thing is, I like this comic strip quite a bit as well. So basically, what happens is, there's this guy who's thinking about new technology and stuff like that. So he's very happy, right? Then what happens is, like new technology is expensive, right? It means you need lots of hardware, right? You buy fancy hardware, right? You buy data centers, you you recruit new people, maybe consultants, fancy data scientists, right? All kinds of fancy people as well. So so now it has cost you lots of money, it has cost you lots of time, and at the end of all this, you have lots of reports, dashboards, lots of nice to have stuff, but you haven't really made an impact, right? So my message, my recurring message is, let's not try to solve problems up to a dashboard level or up to a report level. We should try to solve problems using AI to an action level, right? To a very, very specific set of actions. And that's when it actually impacts your top line or the bottom line. Last slide. This is a problem. Sometimes the organizational resistance is there, right? And sometimes it's not a technology discussion, right? It comes down to people, but sometimes it's sort of misrepresented as a technology problem. But most of the time, the technology is there, but the people and the mindset is not there. I thought I'll just stop at that. And finally, this is my email, sankha@linearsquared.com. Just drop me an email if you need to ask anything. My LinkedIn, as Amanda said at the beginning, I'm the founder and CEO of a company called Linear Squared. Our website is www.linearsquared.com. I'll just put it on the chat. You can check us out as well. So if there are any questions, please let us know. You can just ask questions on the chat. Yes. Okay, are there any recommended AI builders for a person who has no technical knowledge in this specific area? Okay, right, now this is the thing, right? I mean, all of us should learn probably how to drive, but if you want to know how to build cars, right, that's not going to happen overnight. I mean, let be very honest, right? That's not going to be a skill that you're going to develop within a week, right? So that will need dedication, commitment. All of us can't build cars overnight. All of us can if we have the commitment, dedication, that long-term thing. So it might need a little bit of more, little bit of background to be really good at these things. But to drive a car, you can learn quite fast, right? So there are lots of platforms which are available, right? Google has their machine learning platform. Microsoft Azure has their machine learning platform. There are lots of tools, lots of other platforms which are available, which sort of helps you to do things on your own. But again, that doesn't mean that you can do it overnight. That also needs a certain level of training. As an example, what we do at Linear Squared is we actually not even a platform provider. We are a solution provider. We sort of do all the work in the background. But if you really want to get into this field, if you want to learn a little bit of building these things, there are enough resources everywhere on the web. Everything is freely available in Python and R. The neural networks which is used in companies like Facebook, Google, right? All of that is freely available in Python, R, right? Like as an example, TensorFlow is the Google's framework for neural networks, and there's a TensorFlow library in Python. So you can just use those things. But as I said, probably doesn't happen overnight. These skills needs a little bit of commitment and dedication.